So today, Juozas Vaicenavičius, I hope I pronounced that right, CEO of Semestry, maker of SysIDE,
Sensmetry.
Sensmetry, I'm sorry, is joining me. And SysIDE has grabbed attention of SysML V2 community as it's a text-first tool that follows the model to code, model as code paradigm. And so, Juozas, why don't you go ahead with an introduction and why you founded Sensmetry? It's a tongue
Yeah.
breaker.
So I feel that I need to explain why we are called Sensmetry to start with, because that's caught your tongue quite a few times now. So, Sensmetry is because um, we started as a company in automated driving. So after my PhD in mathematical statistics um, and right in 2017, the hype of automated driving, I went on to work in the automated driving industry, and it was truly Wild West. And there was lack of rigor to think about these very safety critical systems, and there was this just general belief, just get us more data and everything will work, and it didn't turn out to be the case. Uh, uh, so so we started Sensmetry, with a team of researchers and engineers from leading companies in engineering industry to start from scratch and think how we can describe systems rigorously that both humans and machines can understand, and in that way be able to rigorously and properly talk about systems, and not just talk through words, but quantitatively. And that's the origin of a company named Sensmetry. So, analogy to geometry, with geometry is the science of of measuring land, and sensmetry is the science of being able to measure sensory inputs and make sense of that. Yeah. So that's the origin story, but you cannot make sense of sensory inputs if you don't know what the sensory inputs, where are they coming from? And that's how SysIDE, came to be. For a long time, we've been working on domain-specific languages from the start to connect the data to the system information, and often generating the data ourselves, based building operational digital twins for complex satellite constellations and similar systems. And we needed a tool to describe a system rigorously that both humans and machines can understand. And we tried all the leading tools available in the SysML v1 world, paid a lot of money. None of them fit our purpose, and didn't meet our needs, uh, meaning being highly scriptable, being able to effectively integrate these tools into CI/CD pipelines, continuous integration, continuous delivery, as is customary in fast-moving software companies. So we had to build our own, and that's how we started SysIDE over 3 years ago, as an internal tool. And then when we saw that it was good, we open sourced it to the world. The first version, SysIDE Editor, as it's known now, and it's been a success. We have around 10,000 users, and this hypothesis that many more people will be interested in this type of way of talking about systems and doing digital engineering much faster has proven correct.
That's awesome. You talked about a lot of concepts from software engineering. You talked about CI/CD. We briefly touched on model as code. Why is that? Do you think that's the way to go?
So there's multiple reasons. So first, reason is that code is a rigorous language, and it's uniquely interpretable and uniquely executable. And that's a huge thing, because human languages are not, English or German are vague languages. We talk the same words, and we get different, perceptions and meanings out of those same words. So that's the first thing. It's the making the system representations as code and allows them to be rigorous as and uniquely interpretable by both humans and machines. And that's why if anyone can see, it's like that's our slogan of Sensmetry: systems as code for humans and machines. So that's and that's that's immediately a huge value. How much time is wasted through things being vague and fuzzy and not properly defined. Yeah, and this we can go into more details later why something like SysML1 was not rigorous enough, and why having a language in as code format is preferable. Another reason is that code is executable. So and there's all the infrastructure available for working very effectively with software systems, and all that can be immediately employed and harnessed to work with system specifications, requirements, system architectures, and all the behavioral specifications, everything that systems engineers and product engineers need to to specify in the same workflows and using the same technologies that software engineers use. So that's another value add. And the third one is that it unifies information and data silos. So the whole organization adopts the software engineering paradigm, as code paradigm and the software engineering workflow. So you don't need many different disconnected tools. Everything lives on software repos, version through Git or similar version control systems connected through continuous integration, continuous delivery, known as CI/CD pipelines, and hardware engineers, systems engineers, product engineers can work without any friction, without any boundaries with with software engineers, and that's not the case even currently in most countries, most companies and industries, because there's a the big wall between hardware and systems engineers that use graphical tools and diagrams, and software engineers that do everything as code. And that's both prevents speed and efficiency in being agile and moving fast in cyber physical system companies. And we know that software is getting produced very fast, and which is not the case with hardware systems having a physical component. And there's more aspects, which is being able to analyze system as a whole. For instance, we have a lot of background in safety and assessment for automated driving and similar systems, and you cannot do safety assessment of an automated system if you don't have a full system model. So much of the modern car is software defined. So if you have that hard boundary, this is my hardware, this is my software, it's not linked through this through the digital threads, and semantically connected, then you lose a lot of very important information, and you cannot do even a proper safety analysis and assessment, because software and hardware interaction is everywhere now. So if hardware fails, then it affects software. If software fails, it affects hardware in a robotic system. It will move differently and do different things. So multiple things, a range of things that that brings tremendous value. Rigor, unification of workflows, execution, and and connecting the semantic knowledge about the system in one format.
And yeah, I think you have like so many interesting topics there. The one thing that I find super important is the job of what you said, unifying data silos. Absolutely. What's interesting here is that you talk about software. So obviously there we have best practices based on open tools and open access to the data. We have hardware, where interestingly enough, I see more and more openness as well, especially with the new breed of tools. But the systems modeling, that's kind of sitting on top of that, unifying it. And that's in my mind what traditionally the requirements management tools try to fill by providing traceability and structure. And so how are you going to tackling these challenges of unifying those data silos? First of all, generally with MBSE, and then specifically with SysML v2 and the SysIDE toolchain.
So first, an answer for the software loving guys is that you don't need a lot of existing tools, because SysML v2 has been engineered to as a language to have requirements, to have structural modeling, to have behavioral modeling, to have analysis and and test cases and many things that these domain specific tools have and that you mentioned and all unified and contained in one language, and all that those concepts exist. For people who are not afraid of code and working in S code paradigm, using IDEs and the everything is available in SysML v2, and you can work very effectively. However, the S code experience is not necessarily for everyone, and there will be people who prefer using GUIs to surface the information that's that's the true representation of the system.
But can I interrupt you for a second?
Yeah, please. Yeah.
Sorry, because I mean, what's interesting is, yeah, you're saying like it has everything, for example, requirements. I agree with that. But looking at the old breed of modeling tools, they were also supporting SysML requirements in a very crappy way. That's why everybody wrote the requirements with, DOORS or JAMA or whatever, and then used recif for one time or regular import, which again, like was not very smooth. So just to say that SysML has requirements doesn't mean that the people who need to work with the requirements are willing to accept those tools, because are they good enough?
Yeah, and that's the second point to it, that
Okay,
I wanted to say
sorry.
but it's not for everyone.
Mm-hmm.
And since it's not for everyone, there's room for these user experiences and that other tools provide. However, I the SysML2 is still relevant, and there's non questionable need to connect requirements to the system architecture, right? And to be able to do that, and having the same concepts in in SysML v2 and as in separate requirements tools allow essentially to open and see requirements, and through this linking to explore them through a requirements tool, and then connect them and link them right to the architecture elements in the system specification in a SysML v2 tool. And if the future is nice and interoperable and something that we try to enable through supporting SysML2 conformance efforts and contributing to the SysML v2 standard as part of OMG, then these requirements tools will be well integrated with the SysML2 tool. So there will be ways for someone who prefers working in a fully as code environment to have these requirements represented in an as code tool as well that currently sit in JAMA or or another tool. So that's what would be a wonderful future of of interoperability, and where people can use the tools that they prefer, and the competition between the tool vendors comes not through proprietary formats and vendor lock-in, as it's currently the case, but through better tools and better user interfaces and providing more efficient ways of working. And if there is a better way of working with requirements in an not a textual editing environment way, and I can see reasons why, that's the area where the tool should shine and should compete against, and not through a vendor lock-in perspective. So yeah, so that's that's our view as a company, and we really want to change how engineering of modern systems is done, and where it's much more similar as in the software world. You can't choose any developer environment to write your software. It can be Vim if you are a very low level hacker type programmer, and you can choose VS Code or whatever, PyCharm, IntelliJ, a paid version of an IDE. There's a wide range, but you can still write the same the same language, and there is no lock-in for using different editing environments or authoring environments. Yeah.
Got it. And I think this is actually like really one of the key things that is changing, and people know that they need to change. But here's an interesting question regarding SysML v2, because that is also hotly debated. So what is the foundation for this level of interoperability? And there's the camp that says that's why we have the SysML v2 API, so that we have a controlled way of interacting with the model. But then if I look at SysIDE, it's like it has a very strong text focus. And there are even some people who say, forget about the model tree, just simply put the textual representation into a Git repository that provides the lowest and best level of interoperability. And I kind of feel that there's like a religious war brewing here on a very small level. So what's your point of view on that?
The desire to have everything as graphical is largely to a large extent cultural, and I can and I'm not disregarding visual representation, the importance of visual representation, and SysIDE supports rich visual representation in the pro suite.
But it's not about visual versus textual.
Yes.
It's about how do you capture your model in text or via an API.
Oh, okay. Understood. So because the assumption was that it's also the visual, typically the typical in a traditional paradigm, the visual model is stored essentially in a model server, in a representation that is not textual. So and so I want to maybe even, so it's a religious war but it's not that that's been around for a very long time, and it's nothing new. And it's so the discussion around, is it essentially a graphical modeling language for that has a non-human readable specification essentially in the how it's stored, and or a textual representation, has been around for decades, and so there is nothing new in that respect. But what we've seen at scale in the software industry, in the which is huge, is that the S code representation won. And we're in 2025. Python is the most popular programming language. Every high school student learns Python, even if no matter what, if you do any technical course, even if you did economics, you do Python these days. And Mike, daughter who is turning 8 is almost starting to write Python code, right? So it's big. We in Lithuania, we have a Lithuanian version of Python, and whenever you start learn how to read, you can write code. If you manage to structure your thoughts, and so it's just that you know, it's there for a reason. And part of the reason is that you have access to the truth. You interact with the truth, with the true ground, ground truth of what your system specification is, or what your program should do. When you interact with the with something stored on a model server, that's not a representation that a human can interpret, and you always interact through some intermediary, which will be some modeling tool. The majority of them are um, you know not transparent, proprietary tools, and not open source. So there's no way to know when you do the modeling what's the true meaning of your system model, or your program. Fingers crossed that that the tools that are that serve you are are translating your visual specification into into the model representation stored on the model server in a model tree. So yeah, so that's and so that's that's also an important, I think, aspect for even as a you know, sort of citizen level, because kind of if we for the S code paradigm and why it's winning, because if our system representations, all our critical software is stored in S code format, which means it's interpretable by both humans and machines. It means there is no way to be fully locked out, because some tool vendor is no longer supporting the tool, or because there is a bug in a tool that no one discovered, essentially, and there is a this something in between the truth, the ground truth, which is which is the model representation that that's stored in a non-human format, and the textual modeling tool. So that's and in that way, in the worst case, we can, as humans, if everything is stored as code, we can go and inspect every print things out, and on very big sheets of paper, and understand how our systems work, how our critical systems work, essentially. If even if we don't have the tools, and and that's very powerful. We have transparency, we have accountability. Yeah, and I think for any critical system that we rely on, that's highly admirable, and highly desired.
So just to clarify, so when you say as code, would that mean that you would see SysML v2 model to be stored in a Git repository in a textual notation, and then just parse it and work with the model tree in a certain way, maybe through the API, versus having a model server which has the SysML v2 API where you can access the model? So you'd say the first one is the way to go, and the second is just something that you do temporarily. Did I understand that correctly? Or do you still see a place for having a model server that is accessed just via the API, where you would retrieve models and then convert into the textual notation to work with them? So those are two very different paradigms. And SysML v2 supports both of them.
Correct. So there is room for both. So my first question, was more of a, advocating for transparency, and why textual as code notation is important and is valuable. And I realized that I haven't fully answered your question on the essentially manipulating system models through an API, and that's uh, manipulating system models through an API, that's great. And this is something that's actually the the most powerful feature of SysIDE. So SysIDE is the engine, being able to read, write, analyze, SysML2 models at incredible speed at the theoretical limits of what's possible, and that's done through an API. So we provide Python APIs, low level as well as high level, for anyone to read, to update system models programmatically, and that's very powerful. But that can still so that still doesn't even if you manipulate through an API, you can still have the representation in the end, which is a textual representation, and still have this transparent as code representation of what your system is. So you can have both, and that's it's not one or the other. You can have both, and that's what we really advocate for. That you can manually directly model the SysML, edit the SysML2 files as code. In many cases, you can even much more effectively update through the APIs, and that's in CI/CD pipelines. That's how you want to change and update things, and that's a lot of our users use SysIDE that way, and that's a huge huge enabler. Yeah, but you can have also the textual representation when the end result is stored that anyone can expect, and you have this transparency and accountability. There's minor details about if textual, and this is we can go into this for a long time into technical discussions, whether everything that's stored in an abstract syntax tree can be expressed in a textual notation, and for all of most practical purposes, the answer is yes. But so yeah, and
I've seen those discussions. Yeah, they're tiresome a little bit.
Yeah, and yeah, and we should really ask a question. What if we cannot express in this textual notation what the model is? Why is it not a little bit of an issue? Yeah. So anyway, that's our work as part of the OMG to improve the standard on these fronts, and we're actively working on this, and already have some proposals, how to combine these two worlds, and and have them live the S code representation and the model server representation coexist in harmony. Yeah, and I'm sure that it will work out well.
Got it. Yeah, super interesting. That definitely helped provide like a little bit of context. So just before I ask the next questions, do you have like a hard stop at 11 o'clock, or can you go a tidbit longer?
Yeah, let's go longer. Yeah, absolutely.
Okay. Yeah, just making sure that you don't have like another follow-up meeting here.
Yeah.
I think again, I think the topic of integration is like one of the single biggest challenges that I see in product development, because we have just too many silos, and integration is brittle and not working properly. So there are two things regarding integration which I think are really important. Number one is just whether you have a point of view on OSLC as a technology. I mean, I certainly have one, but not going to voice it here. But the second thing is, and I think this is really a huge issue, global configuration management. How you see this being solved with SysML v2?
So on the OSLC and interoperability. So we are not changing all engineering fields all at once, and don't try to take sides on the one integration technology versus the other. Because what's critical is to have integration and have that those standards adopted. It's we can have widely adopted interoperability standard. That's what's most important. That's where it becomes practical. So so no strong positions, because currently the situation is that the interoperability is not good, and in the SysML v2 standard, there's different ways of interoperability that are defined, and one through a REST API, another through exchange through kpar files, and that's what we are trying to support, and and when it's in relation to SysML v2, it seems that these would be the main ways of interoperability and and maintaining traceability, and for different tools to work together. On the global configuration management, could you clarify what you mean by global versus configuration management?
So typically, individual ecosystems have their own configuration management, like Git, you can have branches, you can do tagging, and so forth.
Oh,
But when you have multiple systems, each has its own system for doing its configuration system and how to align them.
okay. So you mean a global product level configuration
Yes,
management?
exactly.
Okay,
Yes.
absolutely. Yeah, oh, yeah, that's exactly. Okay, great. So just um, yeah, this is. I think this is first acknowledging a problem. I think this is very important to have global configuration management. Uh, because now it doesn't quite exist. There's like PLE systems that are that take care of more of CAD files and physical designs, and then there's um, you know um, ALM systems that sorry, PLM, not PLE is for product line engineering, and ALM for software, and they treat it totally as separate things, and as separate wells. But again, the reality is that you know the cyber physical products are software and hardware live together, and coexist together, and there is need for unification in configuration management.
Mm.
Um, and I think so SysML2 has a lot of potential to help with configuration management broadly, and it certainly allows it has a lot of sort of again getting back to being able to reuse the same things, and for on Git and version control, but also it has this inside the language language is useful to define different if you have a fleet, how all of these different assets in the fleet are at different systems, and you keep versioning them for Git, and version both hardware and software. So I think SysML2 and that's what have very much to offer, and we want to push this boundary of to fulfill its maximal potential, because the more it lives in one single place and it's more unified, the better. No data silos, the teams work together, and it's both human teams, and also, but it's even more important for for the AI teams, if you like, AI agent teams, because that's that's a big part of the engineering futures. A lot of the traditional engineering work that considered to be human work is to be done by AI agents, and
Mm.
yeah, and having the information all available to them, it's a very important part. Yeah, so a long answer, but so our work is to try to have SysML2 and the Git-based versioning um, to fulfill its whole potential, and see where how far it can go. And our belief is that for quite a few companies, it can be essentially a full solution for a lot of the things. And yes, when if you can connect to to other subdomain specific tools, well, for having interoperability with with other subdomain and tools.
Awesome. Actually, what you just said, like really exploring the potential of this technology is something that reminded me on something that I've been talking with people about a lot. And that's the question, does MBSE have the potential of becoming mainstream? And I became quite disillusioned about that like 5 years ago and said, nah, I don't think that within the next 5 to 10 years it'll become mainstream. But do you see the potential in SysML v2 and the right toolings to help MBSE becoming more mainstream?
Oh, yeah, absolutely. And the first thing is not to use MBSE, as in communicating to the to the broader world. And that's actually exactly what we do. We don't position ourselves as an MBSE company. We say, we are systems as code, system as code and product as code company, because that's something that the majority of the world understands. That's something that's clear what that means. That's something that doesn't have the connotation that's something for only the privileged, and only working in large enterprises and government institutions, and that's I think this is important. That's to from our perspective to communicate, and that's what we try to do. Communicate not that SysML2 is something that's you've been doing for 20 more years, and this is just a slight new update. It's something that's changing, the way we do engineering. It's changing the industry, and it's unlocking all these new opportunities. So that's a little bit ironic, but for us that's important. And yeah, and as a technology, it's underlying it's model-based systems engineering, and there's no other way to go than this, essentially, because it there's fundamental truths about information theory, and that there has to be signal, and signal, and if we don't have rigor, we cannot express signal. If everything is fuzzy and vague, then we cannot communicate signal. And applies to to both humans, and applies both to AIs. And what we are seeing also now in the AI development, suddenly, it's all been about natural language prompting, and you're right, you can talk any of the vague language and it will generate anything you want. No, now it's all shifting again to actually the prompts should be very structured and essentially as a technical documentation and specification, and then the AI is the large language models can do a reasonable job for you. So and the more structured language we have, the better you can communicate the signal. You have higher signal to noise ratio. So there's no other alternative, right, in that respect. What exactly, whether it's only SysML v2, that's a separate topic. There are many different ways, many different potential languages and to express models. But the fact that it has to be MBSE, there's no question about that.
Yeah, sometimes it's necessary to reframe the discussion for making sure that you don't lose your audience, right? Yeah, makes sense. For what it's worth, let me just add at this point that we briefly decided to organize a little webinar where we can actually dive into SysIDE and see how it works. So I think that would be like a really, really great thing to do. There are many, many more things that we could actually talk about, but that would explode the scope of this discussion today. I mean, like, for example, I find the aspect of having a foundation in open source like really compelling, because that's what helped the software industry. But I think we'll save that for another day. Before we close, do you have any specific thoughts or advice that you would like to give to the listeners or readers?
First, SysML 2 is out here and ready, and SysIDE is a tool that's ready to be used, and it's already in production, operating on and enabling some of the very complex systems in space and in other domains by fast-moving companies. So it's available to take advantage of it now, and it doesn't cost anything. So anyone can, start using it. There's a free version that's, free forever, and there is a pro suite that's many times, more performant and feature-rich, having all these programmatic APIs and rich visualization features, and that's also available to start using for free, and it's affordable. So try it, try it now, and try other tools as well. And pick your choice. But be brave and exploratory, because that's the new chapter in engineering, and the ones who will be moving first and embracing the new technologies will be the leaders. So.
Awesome. Yeah, and I can just confirm that I'm working with a customer who's using SysIDE, and for everybody who's used software development tools in general and VS Code in particular, it'll immediately feel familiar. So it's pretty neat. So Juozas, thank you for your time here. This was like really helpful, useful and informative. And hopefully we can schedule a follow-up webinar. That would be really exciting.
Yeah, looking forward to it. Yeah.